Okay, today is a new chapter, chapter 16, and it's about polar coordinates. This was one of the topics that is recommended for a high-level pre-calc class. And it's really, honestly, this may be one of the easiest tests all year long once you get this. You have an easy one coming in to help out for the fact that you just had one of the harder tests that you've had. So I know you all know how to graph. You go over and then you go up to get to that dot, but there's no reason that it would have had to have been that way. If you're telling your friend and you're out on a big field, okay, I'm going to back up a second here, add a blank page. Okay, sorry about the interruption there. If you were out on a field somewhere, it obviously would help if you are on a grid like this, okay? But if you're trying to explain to your friend how to get to this spot over there, you'd say, well, kind of go to the right and then kind of go, well, all depends. If you're standing in a field, is there really a right and a left? Depends if your friend's looking at you and you're looking at them. I mean, it's complicated to explain how to get to a spot. But if we had it all divided up like this, you'd probably default back to your old way of saying, well, go to the right this far and then up that far. Okay, but we could tell the friend to go in, what are those things called that we learned at the beginning of the year? Bearings, yes. You could say, I want you to head at, do you remember how this worked again? Yes, something degree true. Very good, okay. And would you agree that it's less than 90? So could you agree that you're heading at a bearing of about 80 degrees if you head that way? Head at a bearing of 80 degrees for about, well, I don't know how many feet that is. If you're on a soccer field or something, maybe it's 100 feet. At a bearing of 80. That's another way to get to a spot, right? Well, polar is just another way to get to that spot. So let's say that I say that that spot is, let's say, 5 units from the origin. Okay, the distance that the person would head is 5 feet, 5 inches, whatever. Okay. Then, do you get that sort of forms an angle here? What if I said that angle was 30 degrees? Wait a minute, sir. A second ago you said it was like 80 degrees or whatever. But if I wanted to, I could make it just like unit circles that we just did, and say that that spot right there is at r comma theta. R being the radius. You get how this sort of makes a circle, kind of like a circle's radius. R of 5 comma angle is 30. Except we are beyond 30s nowadays. What do we use? Pi over 6. That spot is at 30 comma pi over 6. Sorry, 5 comma pi over 6. Now, couldn't you still be stubborn and say, but I want to give it in x and y? Yeah, you could, and look how it makes a right triangle. You get what I'm saying? And so I could still say that in polar it's 5 comma pi over 6, but in rectangular it's x comma y, and can't I figure out how long x and y are? Oh yes, I could. I could use law of sines. Very good. Haven't heard that combination of words in a while. Okay, just as a quick offshoot, that's a over sine big A equals b over sine big B. But you don't even need to use something as complicated as law of sines. You can use just plain old-fashioned trig. Would you agree that sine of 30 equals y over 5? Do you get where I'm going with this? And then I could solve for y and figure out how big it is? Didn't I ask you to memorize sine of 30 a long time ago? It's 0.5 or 1/2. But if you didn't know it, do you get why right now I am drawing the classic 30, 60, 90 triangle? Classic 30, 60, 90 is the 1, 2 root 3. And so if I want the sine of 30, I can just go opposite over hypotenuse. That's 1/2. Please stop talking. Y over 5. And then I'm going to multiply both sides by 5. And then I would get y equals 5 over 2. See what I just did there? All right. So this is 5 over root 2. Would you please figure out how long x is? It was 5 over 2. Figure out how big x is. You can do that in a couple different ways. You could do a trig equation like I just did, except it wouldn't be sine of 30. Figure out x with either a trig equation or by using what you know about the 30, 60, 90 triangle. Okay? I personally like the trig equations because to me, when I see that 30, right away it wants me to write like sine of 30 or cosine of 30 or whatever. So in this case, I'm going to do cosine of 30 is equal to x over 5. And then I just got to figure out what cosine of 30 is, and I'll times both sides by 5, and I'll have it. You get that way? That's all way. Some kids would rather do this and go, well, x is kind of like the root 3, right? So would you agree you could set up a proportion of x goes with root 3 like 5 goes with 2? And then I could multiply both sides by root 3. The final answer is 5 root 3 over 2. Raise your hand if you had that one. Awesome. Now, what did we just figure out? We just figured out that that point that was so easy to write in polar is kind of a pain in the butt to write in rectangular. Its x is 5 root 3 over 2, and its y is 5 over 2. That make sense? All right, I know the first time you see something, it doesn't always process perfectly, but if I give you another one, I bet you'll have a good chance of getting it. All right, I'd like to say that that is a nice 45-degree angle, so I'm not going to say 45. I'm going to say pi over 4. And let's make the radius of this thing 8. So this spot right here would be 8 comma pi over 4. Then my question is, that's in polar. What would it be in rectangular? As in, how far is this? How far is that? So that's what comma what in rectangular. I'll pause for a second while you figure this out. All right, so you should have been thinking, I feel like I recognize this triangle. It's got a 45 here, and so that means, it's 118. No, that can't work, right? That's kind of mixing a couple triangles together. But there is a triangle that's like this. I always like to put the classic one in my picture, 1 root 2, and then if you want to do it with side ratios, it'll work. I can say this is x and this is y, and I can do side ratios. If you'd rather write out trig equations, you could say sine of 45 equals opposite over hypotenuse, y over 8, and then I just got to figure out sine of 45. Well, it's still handy to have this guy here, because then I can do the sine in that classic right triangle. Sine is opposite over hypotenuse, 1 over root 2. So this part's 1 over root 2. I got 1 over root 2 equals y over 8, and I multiply both sides by 8. I got 8 over root 2. All right. And was that for x or y? Or both of them? Both of them. All right. So that one is 8 over root 2, 8 over root 2, because they're the same. Right? Because these will have to be the same as each other. If you did it twice, you were not thinking. But you probably came out with the same thing. Good question. Can you simplify it? Absolutely, if you want to. But I'd have been fine with 8 over root 2. But did you use the multiply by root 2 over root 2 thing and get 8 root 2 over 2? Which would be, yeah, you can simplify it more if you want to. I'm taking this and multiplying by root 2 over root 2, because that's like multiplying by 1, right? And that's 8 root 2 over root 4, which is 2, and that's 4 root 2. I'm assuming that's what you meant by simplified. Okay. All right, are there any other questions about how to take polar coordinates and how to get them to be rectangular coordinates? All right, let's just make sure you really get polar first. So here is another place in polar. I want you to put it where you think I mean. 8 comma 7 pi over 6. Put a dot there. 8 comma 7 pi over 6. Don't say it out loud. Don't use your words. Put a dot on your iPad. 8 comma 7 pi over 6. I like to think in terms of making the 7 pi over 6 line first. That's about the right spot. And then I just call however long I made it 8. Raise your hand if you had a dot in that general vicinity. Okay, good. And if I asked you to make the coordinates for this, do you get that you'd have to be careful because that one will be a negative? It'll be going down. Okay. All right. Yes. Okay, I understand. All right, so my next trick is if that spot right there is 8 comma, set them right there, thank you very much. If that's 8 comma 7 pi over 6, it's also something else. Just like before when we said, oh, this spot is called something on the unit circle, but you could actually get there like 5 different ways. You could go negative, you could, etc. Then can you tell me what would also be here? Another way to write this spot is 8 comma, there it is, 8 comma negative 5 pi over 6. Do you get, it's just a different way to say the angle with using a negative? All right. Now, this last one is going to blow some minds. Okay, sorry about the interruption there. So, this next one is going to blow some people's minds. Would you agree that this spot over here has some symmetry, at least, with the spot in question? Okay, and I can give a name to that spot. It's not that tough, because if I mean for this and this to be the same length, which they aren't quite, but maybe it's closer now, I don't know. Okay, if I mean for that to be the same length, then obviously it's 8 comma something. What would it be? 8 comma what? 6. All right, 8 comma pi over 6. Now, just a second, just to be clear, those are completely different points. But it helps me to write a new way to say this point that, again, is going to stretch some of you. This point could also be written as, would you agree that they're going the opposite direction as each other? Maybe that'll help you to think of a negative as the opposite of. Negative 8 comma pi over 6 is another way to write this point. Just ruling that out. Nope, doesn't work. Doesn't make any sense. Just think about it. If I am here and I ask you to go to the opposite of there, you'd kind of go, okay, fine, I went out here like I thought you meant, but no, I guess I'll have to go back the opposite way, and then you'd end up right there. All right, then, what's the last way to get there? Never a good sign when the teacher has to hit the extend page button. Ooh, negative 8 is correct. Comma, and what did you say again? Negative 11 pi over 6 is correct. Now try to figure out what he just did there.
He's going all the way. He's going all the way around town. I could do it like forever.
Do you get that this pi over 6 was getting here in a positive direction, and then he just did the opposite of that, got there in the negative direction? So I just showed you 4 ways to write this point, and that's like half your assignment for tonight. The other half of your assignment for tonight is to take polar coordinates, make a right triangle out of it, and figure out the x and the y, and you'll have the rectangular coordinates for it. So let's just sum it up by doing one of each kind. Question first.
Where did you get the -8 for the last?
The -8 for this last one. Well, think of it this way. I gave 2 ways with a positive r and 2 ways with a negative r. If I want to use the negative r, I make this helper point over here, which isn't even the point in question at all. It's just going to help me to write this as a negative point. So I go over to this spot and then say, but I don't really want that spot. I want the one opposite from that. So you take this and then just make it the opposite, and it makes it go over here. All right, let's try one more like that. Let's say I give you the point 5, comma, 11 pi over 6. Figure out where that is. Put a dot. Then give me 3 other names for that spot. I hope you knew that 11 pi over 6 is headed that way in general. Maybe has a little too small of an angle, maybe more like that way. Okay, and then this is out 5, let's say, and I don't know, you be the judge of whether or not that's 5, but all right. So, did you have your dot in the right spot? Raise your hand if you were in that general in the vicinity. Okay, good. Then there is 3 other ways to write that. Another way with a positive 5. And you almost might want to just write them all like this. Another way with a positive 5 and 2 ways with a negative 5. And just try to figure them out one at a time. My suggestion was to make a helper point. One of my favorite Simpson episodes is the one where Homer gets a helper monkey. I don't know if you remember that one. But Mr. Q, can you tell me about the helper point in question here?
So it's in quadrant 2.
Okay, agreed. I'm going to extend this line. Oh, that we didn't go very straight. Close enough. Okay, now what?
And it's pi over 6 above the x-axis.
That's a pi over 6. Agreed. Okay.
Then there you can find the 2 coordinates.
Which would be?
-5 and 5 pi over 6.
Hold on, this is a 5.
Oh.
Comma.
5 pi over 6.
5 pi over 6, which makes this spot over here then -5, comma, 5 pi over 6. Good. All right. And then another way to get here would have been to say that way. Wait a minute, that's the way I did. Sorry. Another way to get there would have been to say that way, which would have been what? -7 pi over 6. And then the last way I haven't got yet is just another way to write this, 11 pi over 6, except with a negative, which would be negative pi over 6. Raise your hand if you had that one right. Sweet. Then, last question for today. What's the rectangular coordinates to get there? Like x, comma, y. What's the rectangular coordinates to get there? Well, I know this distance is 5, and now I know this angle is a 30. I know that might bother some of you because it's technically negative pi over 6 or whatever, but it's just a 30, 60, 90 triangle, right? that helps to write out the 30 and the 60. I like to make my classic helper triangle in the same orientation so that they both have like their tops look the same, you know. And then this side's on a classic 1, 2, root 3, which then lets me go 5 is, actually I should put in an X first. That's going to be my X, that's going to be my Y. I'm going to say X is to root 3 as 5 is to 2. Final answer, 5 root 3 over 2 is my X. Raise your hand if you had that one right. Awesome. That spot right there is 5 root 3 over 2, comma, what's the Y of it? And be careful, it's negative because it's going down, right? Then I could go Y is to 1 like 5 is to 2. So then Y equals 5 over 2. Okay, that pretty much covers. Is that what you guys got, first of all? Did I do something wrong there? Okay, thanks. All right, I'm getting several smart people agreeing with me. All right, so then let's look at your homework. Everybody find your homework for today. It's right here. You're going to be doing 1 and 2. Let's just go through and show you which ones we're doing and not doing here first. 1 and 2, you're going to do 10 and 12. Then you're going to skip the purple page. Okay, so cross these out. Then, on this page, we're going to cross off 40 and 45. And I think that cuts it down to a reasonable number of questions. Since we're on this page anyway, let's start here. And it says, convert from rectangular into polar? What? We didn't ever do that. Well, you can figure it out. Over 0, up 5, would you agree that that's my spot? It's really not too hard. It's actually way easier. So now I just got to tell an R and a theta. What's my R? What's my theta? No. False. Pi over 2, yes. 2 pi is what I was hearing was not correct. Okay. Pi over 2 is correct. Okay, so then, all right, that one's done. How about we do on this a little bit harder? It's got a 3 and a root 3. Ooh, you remember that one? Remember how 3 over root 3 was a lot like 3 over root 3 was like another ratio we like better. Oh, sorry. Root 3 over 3. Sorry. Root 3 over 3 was a lot like a different ratio that we liked better, which was what? 1 over root 3, and that'll be in the 1, 2, root 3 triangle. So I already know right now that's going to be the 1, 2, root 3 triangle, and that tells me that it's probably wherever it is, a 30 or a 60. All right. So I go over 3 and up root 3. I know you don't know how far that is, but you know that that is root 3, and that is 3. And then you can tell what those coordinates must be as long as you can refigure out that it's not really 3 and a root 3. It's more like a 1 and a root 3. Okay. Now I'll leaving 39 for you, which is nice and easy. So let's go back to one of the very beginning ones here. Please try putting a dot in the right spot. Put the dot in the spot for number 1. If pi over 3 is your angle, I'm going to say it's about a 30-degree angle. Looks like about that. And then how far this is totally up to you. I'm going to say that that is 2. And there we go. Oh, it's a 60. Thank you. It's pi over 3, not pi over 6. Sorry, I should make it a much steeper angle, more like that. Okay. All right, so that's my first spot. Now, all they're asking with all this complicated stuff here is to make your R's positive and negative and make your angles positive and negative. So the first spot was this. What are the other 3 spots? Well, the first way I would recommend is make yourself a little triangle for this guy, and it's that's a 2, and that's a root 3, also known as a 60. Okay. So I need a bunch of spots for this. One of which is to just give a different way to get there. 2 comma, instead of saying 60 or pi over 3, you would say around this way, which would be negative a bunch of pi over 3's. How many? 5 pi over 3. I agree. And then you'll need the helper monkey, or in this case, the helper point, which is down here. And it tells you a point that you're going to use to make this negative 2 comma whatever. All right, but this helper point is 2 comma, and then if that's a pi over 3, that's a whole bunch of pi over 3's. It's 4 pi over 3. But if you write 2 comma 4 pi over 3, your dots would be here. That's not the same spot. So negative 2 comma 4 pi over 3. And then there's just one more way to write that, where you say this angle not as a positive, but as a negative. All right, that's as much help as I can possibly give you on that part. And that's all I have for you for today.